we are Team Nucleus and my name is Brian. In this lab we are imitating osmosis by testing an egg. Our egg's name is Maximilian Williamson Schleifer. The problem in this experiment is how can we observe osmosis across a semi-permeable membrane?
What we already know, or our background information, is that there are two main types of passive transport, simple diffusion and osmosis. Osmosis is the movement of water through a concentration gradient. The water flows from high concentration to a lower one. Hypotonic solutions have a tendency to swell up, getting larger, then burst, since the solution has less solute, more water, shown here in this picture, and then hypertonic solutions normally cause cells to shrink due to lack of water and more solute. So water will leave it to try and make it equal. For our hypothesis, we said if we mimic an egg as a cell without a shell in it to copy the process of osmosis for a cell using water, cornstarch, and vinegar, then the egg will react as the cell would in the process of osmosis.
Okay, the constants in this experiment, which remain the same throughout, are the cup, the egg, the amount of the solution, and the time that the egg is soaked in each solution. We also have independent variables, which is what's being tested, and that would be the solution the egg is being soaked in, which is the corn syrup and the water. The dependent variable is what's being measured, and it's the egg size, the weight, and the physical appearance. And lastly, the control group is just a plain egg soaked in water.
The materials for this experiment are a raw egg, vinegar, a ruler, scale, water, spoon, bowl, plastic cup, corn syrup, and yarn. Now for the experiment. Soak one raw egg in a bowl of vinegar for approximately 5 days until the shell is completely dissolved. Second step in the experiment is measure the eggs, take the egg out, measure the egg's circumference, long and wide, and weigh the egg. Record the measurements in a data table. The third step is to mix the solution with 2/3 corn syrup and 1/3 water. Place the egg in the cup, pour the solution into the cup until the egg is completely covered. Be sure to push down on the egg to keep it from floating. Soak it in the mixture for 24 hours. Remove the egg from the cup and measure its circumferences and weight. Record your measurements and changes. Empty your cup. Sixth step, replace the egg back into the cup and fill the cup with water until the egg is completely covered. Be sure to press down on the egg to keep it from floating. Seventh step, soak the egg in water for 24 hours. Eighth, remove the egg from the cup and measure its circumferences and weigh if possible. Record any changes in measurements, and finally, you have just completed the egg lab. Now we do the conclusion, and we must collect our data by putting it together in a data table, like so. Day 1 of the experiment, the vertical circumference was 20 centimeters, the horizontal circumference was 17 centimeters, and the weight was 83.4 grams. The observations were it was a whitish elastic, but it was floating. Day 2, the vertical circumference was 15 centimeters, the horizontal circumference was 13 centimeters, and it was 55.5 grams. Our observations were that it was whitish, soggy, and it sank. Day 3, the vertical circumference was 18 centimeters, the horizontal circumference was 14 centimeters, and the weight was 84.3 grams. It was whitish, elastic, and it sank.
So this is our graph of our data, and the line shown here is the weight. So as you can see, when we put it in the cornstarch, it weighed less after, and then when we put it back in the water, it weighed about the same as it did from the beginning. For the circumference vertically, we have this yellow line here, and you can see it went down a little bit with the cornstarch, and then it went back up in the water, and same with the horizontal, which is the blue line right here. It decreased a little, and then it increased again.
After creating and testing our experiment, we can now successfully answer the problem. By designing an experiment that puts the egg through the similar scenarios of osmosis, we were able to observe osmosis through a semi-permeable membrane. The hypertonic solution brought the egg down to about 75% of its original size. The egg lost 34% of its original weight. An animal cell going through osmosis in a hypertonic solution would shrink as well. Therefore, the hypertonic environment was correctly represented. The egg was placed in the hypotonic solution and expanded in size by approximately 120%, and it gained 152% of the weight back. This successfully represented an animal cell placed in a hypotonic environment. It showed great change compared to the control egg, which remained about 80 grams. The experiment would have showed clearer results if we waited until the egg grew back to its original size after the hypertonic experiment before conducting the hypotonic part of the experiment. Also, a bar graph would have represented the data much more better. But all in all, the experiment was very successful, and we had a great time doing this project.
Our groups for the experiment are, wait, what?
Less solute and more water.
Yep.
Oh, my shadow.
Let's scroll down a second.
Wait one sec. Mary. Try over here. I don't know. So this is our data table, and this line right here.
There's our graph.
When the egg was placed in a okay. Therefore, I'm reading the wrong line. Also, a bar graph would represent the data more clearly. Oh, yeah. I can't get the stupid button. I can't find your mouse. Oh wait, it's up there. Come on.
Are you in the